Hello, my name's Terry. I'm a software developer and high school math teacher, and I'm very excited to introduce to you computational math, solving math problems by designing, coding, and testing algorithms. Computational thinking is framing a problem so that it can be solved by a computer, and it's becoming increasingly important as computational devices become ubiquitous. We are seeing an accelerated growth of digital data, and the only way to analyze, to interpret, or to learn from this digital data is to learn the basics about coding, and it's a new means of problem solving. This is quickly becoming the literacy for the 21st century. Unfortunately, computer science is not being taught in our high schools, and we want to take those few elements of computer science and focus specifically on problem solving, because learning these skills can lead to some of the best jobs and careers of the 21st century. Whether you want to be an economist, an educator, a scientist, or an artist, learning the basics about computational thinking is a valuable skill in the 21st century. Computational math, it is solving math problems by designing, coding, and testing algorithms. We take the exact same problems we see in our high school level math classes and we solve them by computational methods. What are the advantages of JavaScript? That's the language we use in this course. It's the language of the web. It is ubiquitous and is interactive. Whether you have Chromebooks, PCs, or Macintoshes, we can use JavaScript in any of those environments. Computational math, with JavaScript, we assume this is the first time you're learning how to code and that you have no prior experience. We'll start by learning the 25 key coding concepts such as iteration, looping, branching, variables, functions, and we'll apply those specifically to math problems as a supplement to your math classes. So let's go ahead and take a look at some of the sample problems that we can do using computational methods. So I'm going to go to my JavaScript course here at everybodycodes.com and let's take a look at some examples. One of the basic problems might be adding two numbers together. We can, for example, do some statistical problems such as simulating rolling dice together or generating a random number or building a table of XY coordinates for a polynomial. Let's go ahead and get started. Here, the most simple one, add two numbers together. We can add this, test our algorithm, and see what results we're getting. Let's change the input and test it again and continue. We can continually test and design and refine our algorithm until we are ensure that we're doing solving the math problem correctly. Let's go something a little bit more interesting. Let's calculate the factorial of a number. What's the factorial of 5? Well, we can use iteration and see that it's 120 here. We can let's find a little bit larger number here. Let's do 15. Find the there, and we see it's a very large factorial number. Again, a basic problem that we can solve using computational methods. Let's build a table of XY coordinates for a polynomial. Okay, so we can use this here to represent the coefficients of a polynomial. Here's the coefficient to x to the third, second, x, and the constant. For example, we have a range here that we're going to build our table, and an increment that we're going to build in. We can click this, and we can see here's the XY points. We can graph this, or we can actually just write a program that runs that, and can, in this case, we can see our parabola. Let's go back and look at some other examples that we can do. Basically, we're going to learn to write code for all of these problems. We can show a table of Fahrenheit to Celsius conversions or calculate the sum and average of numbers. We can use geometric series. We can determine whether a number is prime. We can calculate the area under a polynomial. This is something we'll do in calculus often, and we use, instead of using integration, we can use computational methods. Here we can do some statistics-like problems such as simulating shuffling a deck or dealing decks and calculating the odds of blackjack. Let's find the factors of a number. Here's a good one. Here, what are all the factors of 99? We can use computational methods to solve that, and we can even make the number substantially larger and use computational methods here. So let's try a number such as this, and near 10,000, and we get all of the factors for a number. Other examples can be, for example, and this is just a sampling, calculating the area under a polynomial curve. We talked about that one. Calculating the distance, flight and time, time in flight, and the maximum height for a projectile, a physics type problem, given the initial velocity and the angle from the horizon. Let's find all the some prime numbers less than or equal to a number. Here's a challenging one. Here we have a number. Let's find all the prime numbers less than 100 and sum those all together, and we get 1061. Let's get something closer to 10,000. Let's find all the prime numbers up to 10,000, and we sum those together, we get a huge number. And if we just look at all the prime numbers less than 10,000, I'm scrolling down here, we can just see This is something that would be virtually impossible to do by hand, but using computational methods and iteration is something that we can do quite easily. Another example would be find the roots of a polynomial using the bisection method. So that's another way that we can use iteration and quickly find our solution. So this is just a quick sampling of some of the problems that we can do using computational methods. These are exact same high school level problems that we see, but we can now solve them in a different way to supplement and to rethink about math, and so that students can have a greater mastery and understanding of the material. In addition to the actual code, where we're going to learn how to code and practice and solve those, you've seen the end product of what our students will be able to do by taking this course, but we also have flowcharts which discuss all the inputs and outputs and the actual algorithm, understanding the algorithm using flowcharts before we begin to code. This, for example, is finding the square root of a number. It's a different approach than factoring that we would use if we were doing the same problem by hand. So if you are a K-12 teacher or educator, please contact us. We welcome you to use our curriculum. We start by extensive teacher training. So we will spend time with your teachers to learn all of the basics. We understand that we expect that your math teachers will understand the math, and we're going to teach them all of the coding concepts, all of the computer science things, just the basics, so that they can now take those exact same math problems that they teach every day and solve them using a new methodology. We have an extensive online curriculum. We have extensive database of problems, and we provide support. We'll help you set up your computer labs and get you started so that you can teach computational math. So how to get started, contact everybodycodes.com. Schedule some teacher training. We'd love to work with you. We'd love to teach you as teachers all the fundamentals, everything you need to know about coding, and then let's take some small steps. We recommend that you start by first, after you've taken the training, you've learned the curriculum, you looked at everything that's online, we start off by doing a code club. You get some interest in your school, you get some people involved, and then after you're comfortable with that step, we can take the next step and actually start a computational math course, which will be a supplement to your existing math program. Computational problem solving. It's the new literacy for the 21st century. We welcome you to learn more at everybodycodes.com. Thank you.